some of you were wondering what's with the whole zooming in and zooming out, right? So, for example, on page 17 here, right, we had 3 favorite paintings that need to stay together. So I went 3 factorial within it, and then I zoom out, and I count this as 1, right? 1, 2, 3, 4, 5, 6. There are 6 slots that can be moved. That's where I get the 6 factorial from. And so ultimately, you go 3 factorial times 6 factorial to get the total number of ways to rearrange those paintings. Okay, so here's another, I know the number of items is different. Let me see if I can work this thing. Okay, so let's assume we've got 3, 6, we've got 8 people that are lining up for a picture, and 3 need to stay together, right? So within the 3, right, let me just ungroup this once. Ungroup, right? So you can move them around within that, right? That's where you would get your 3 factorial from. And then you zoom out, it's almost as if, right, you group these together, right? So let's for now just assume that this group is going to be replaced. We're just assuming that it's another piece that we can move around when we zoom out, right? So instead of having the 3 here, just assume we are left with 1, 2, 3, 4, 5, 6, right, when you zoom out. So that's the idea here. So I count this as 1 slot, right? For a moment, I'm just going to replace it. So these are the 3 people that need to stay together, and I can move them around like that, right? So that's why we go 6 factorial when we zoom out. If you have a group of 3 and another group of 2, let's say, so let's pretend these 2 have to stay together. Okay, then if you group them, okay, you would go, how would we answer this? We would say, well, there's a 3 factorial there. There's a 2 factorial ways of moving these 2 people around. And when you zoom out, it's 1, 2, 3, 4, 5, 6, right? 6 groups on the outside. And so for a moment, I want you to just think these are just replaced by 2 slots, so to speak, right? They're in here, so there's 6 left. So I can move the 2 or the 3, I can move them around every which way I want. So there, for every group, there's a factorial, but there's always going to be this one. Oops. There's always going to be this one that is the zooming out part. That's the one that tells you like how many groups, how many slots are there that I can still move around if I were to zoom out and take each one of these separately, right? So this, let's move these out right now. Okay. So there's 6 slots all across that I can move around, right? I can move these 3 back here and have it like set up like that, right? So you're moving these bigger chunks around as well. But that's where the 6 comes from, okay? I hope that's another way of looking at it, right? Looking at it this way. Hopefully that helps you a little bit to envision what's happening when you're having to keep things together. One common mistake that I don't want you to make is sometimes students think, oh, 3 together, so that means that these remaining 5 are together also. No, it's not. The question would have to say that, right? If it just says 3 are together, the remaining are individual pieces that you can move around every which way, right? So we had the staying together. I hope that one you can do at this point. Then we had the identicals on 24. Okay, moving forward, if you have things that are identical, the first classic component, and I can almost put money down that you're going to have one on the exam. I'm not going to put money down, but I can almost bet you that there's going to be some sort of long word, and you're going to see, oh, there's repeats. So they want you to obviously count the number of letters. That's the one you put at the top, and you put a factorial to it, and you divide out the repetitions. And why are we dividing it out, folks? We're dividing it out because we don't want to count the E's being switched because we can't tell them apart. They're not unique permutations, okay? So we basically divide out as many as there are. I don't know if you did the Mississippi one. Was there a Mississippi? Yeah, on page 26, for example, Mississippi is right there. So you've got 11 letters. There are 4 S's, 4 I's, and 2 P's. This is on page 26 at the very top. So we count 11 letters, and then we just go 4 factorial, 4 factorial, 2 factorial. That's all happening in the denominator. Please refrain from just going 11 factorial divided by times. You're going to get it wrong. You need to put this in brackets if you want to do it all in one shot. Then you need to make sure when you go divide, you start with brackets and then you multiply these, okay? I actually went 11 factorial up top, then I went 24 times 24 times 2 to give me this. And when you divide them, that's your last step. You have this many ways to rearrange it, okay? For now, I'm going to pause there. What were the questions from the homework that you needed me to? Okay. So question 9 said you must create a 5 to 7 letter password with no repeating letters. How many combinations are there? Yeah, when it says 5 to 7, you can't do them all in one shot. You have to do cases. You're gonna have to go 5 letters or 6 or 7. Okay, because you gotta like do the slot thing. Okay. And did I post this version of the key? 26 pick 5 is essentially, I'm gonna need some scrap paper here. That's basically if you were to do 5 slots like this, okay, if all you have is, what is it? A letter password. So letters, we're doing letters, so that would be 26, 25, 24, 23, and 22, right? You're filling in 5 slots. That is essentially 26 pick 5, okay? We're picking 5 out of the 26. And then the 6 letters, as you can imagine, there's going to be 6 slots, so it's 26, 25, 24, 23, 22, 21, that is essentially 26 pick 6, right? You're doing 6 slots. Got it? Okay. All right, so, and then you got to add them up because it's OR, and so you got a lot of options here because you can go from 5 to 7, right? Did you know some sites, if you want to make your password, there's actually a limit, like there's a max. Like I tried, nowadays I almost write like a paragraph as my password, just to make sure nobody can hack it. But some websites actually, oh, that's too many characters, you got to go fewer than that. I'm like, come on, I just had something good going here. But there's a max sometimes, and there's also a min, right? A lot of passwords say, hey, a minimum of 7 characters, right? So there's a lot of restrictions there. Do you guys remember what does case sensitive mean if you make a case sensitive password using letters? Well, capital and lowercase. So how would that change here? This example right here. Instead of 26, what would I start with? You've got 26 and another 26. You actually have 52 options. So it'd be 52, 51, 50, and so forth. Okay. So that's something to keep in mind. I think I just want to make sure if you did the work, okay. For example, on page 22, you had some biology, chemistry, bio, and physics books, right? If there's no restrictions, where's 12? 12 is right. No, 13, sorry. 13. 13, we had no restrictions. There were 12 books. So it's 12 factorial, right? 12 books that need to be put in the shelf. So it's almost like lining up for a picture side by side, right? If you wanted all of the biology together, this is your bio, there's 4 of them. So you have 4 factorial. Then you zoom out and it's 1, right? 2, 3, 4, 5, 6, 7, 8, 9 slots remaining. That's the zooming out. That's 4 factorial, 9 factorial, okay? If you want them all together, like the 5, what was it, chemistry, 4 bio, 3 physics, you're actually making 3 groups. So there's 5 factorial, 4 factorial, 3 factorial, and then that last one here is zooming out. You've got 1 big slot, 2, 3. So there's 3. You can move these, but only together. They need to stay together. So this one could go there, the 4 can come here, but there's only 3 factorial at the end. I hope you tried that one, right? That's also a very classic question, keeping things together, okay? All right, I wanted to talk about page 25. Let's go to 25. What happens when you get that scenario? I don't think it's very common, to be honest, but I need you to be prepared for it. And I'm going to use a brand new version of it. I want you to go to 25, where we have Canada as the word we're trying to scramble, right, and make other words. I need you to understand that if you're asked to figure out how many permutations or how many ways to arrange that, if it says no restrictions, some students think, oh, I don't have to worry about the doubling. I don't have to worry about the repeats. You always have to make sure you divide them out. There's no question about that. So Canada, there's 1, 2, 3, 4, 5, 6. 6 letters, so n is equal to 6. You've got 3 A's. Is that the only repeats? That's the only repeat. So this will be 6 factorial over 3 factorial. 6 factorial is 720. 3 factorial is 6. So there's 120 ways of doing that. What if the first letter has to be an N and the last one has to be a C? So remember, you have 6. 6, so the first one has to be N. It's just one option. The last one has to be a C. Just one option there. How many do you have left in between? There's 4, 3, 2, 1, right? There's the 4 letters that remain that still need to be scrambled. Are you awake for this part? Okay. If you just go 1 times, this is technically 4 factorial or 4 pick 4. And there is the 1 there. You would not be 100% correct at this point. You still need to divide out the 3 A's, always, okay? I will say this, these are the 3 A's, okay? You need to make sure you figure that out. You divide that out, no matter what you do. So take care of the restrictions, do everything you need to do what you would normally do, but then don't forget to divide out the repetitions, okay? So this would be 4 factorial divided by 3 factorial. What's 4 factorial? 24, this is 6. So there's only 4 ways. There's very few ways because of the repeats. Because if you think about it, what's left, if you take the N away and you take the C away, there's 3 A's and a D left to fill in here. So those 3 A's, even if you move them, we're not counting them as separate permutations, right? So there aren't a whole lot of different ways to set up the remaining letters. That's why you're only down to 4 ways of doing that. I will make a note here. Always divide out repeats, okay? Make sure you have a note, you have a cloud, and you have it highlighted, okay? Because can't tell you how many times students do everything else. It's just beautiful. They accounted for the N, they accounted for the C, then they come up with 24, but they forgot to account for the fact that there are repeated letters and I need to divide them out. and for as many occurrences as there are. Okay, so if there had been a couple of n's, like let's say there's two n's, and you have to make sure 2 factorial goes in here. Okay. This is the one that doesn't happen very often, but I need you to know how to handle this. So if the first letter is an A, make a note here. Keep in mind, this is a repeated letter, okay? Keep that in mind. I will also highlight that part. This is almost a case worthy to have on your study sheet, okay? Have this on your study sheet. So how would we do this? So let's go with Canada, 6 slots. Draw out 6 slots here to get started. Okay? How many A's do we have? A. So if the first letter has to be an A, we've got 3 options, correct? Would we actually consider 3 options though, if they're all the same? So what I want you to do is, I want you to say, technically we have 3 A's, but we're gonna say, nope, we're not gonna consider them 3, we're just gonna consider it 1. Because all the A's are exactly the same. So we're just gonna say there's only 1 option, really. We're not gonna consider all 3 cases. We're not gonna be like, oh, case number 1, there's the A. Case number 2, there's another A. We're not going to do that. We're just going to count it as 1 instance, even though there are 3 options. Okay? And what you need to do now is, for the remaining here, how much is left here? So we have 5, 4, 3, 2, 1, right? You grab 1A, and then the rest go over here. So it's 1 times 5 factorial. So you would go, when you're about to solve, you would go 1 times 5 factorial, and what would you divide out here? Your instinct would tell you divide out 3 A's, okay? The 3 factorial, but we'll just divide it by 2 factorial. 1A is fixed, 2 A's remain. Okay, let's go over here. There are 3 A's. 1 is fixed. Where is it fixed? It's at the front. It stays. Like you take 1A out, you put it at the front, and then you scramble the remaining 5. You put it all over the place. How many A's are in this 5? There are still 2 A's in there, right, being moved around. So that's why you only want to divide out 2 factorial, not 3 factorial. When the repeated letter is at the front, right, then you want to take it away from the dividing out the repeats. Okay? So this is how it changes. It changes because of that. So 5 factorial is what? 120. 2 factorial is 2. So that's 60 ways of doing that. Okay, I'm gonna, yeah.
On your answer key, you put you would divide by 3 factorial. So
I did. What page is this? 25. I wonder if you are right. My key is off. Sorry about that. I'm off. I was wrong. I'm going to update that right after today. Can you please change it? If you looked at my key and you copied what I did, Can you make sure you account for that? It's very important. I don't think it's gonna show up. They don't necessarily, like, they don't really like this one because it's very, like, it throws students off, but I'm not gonna guarantee you that it's not gonna show up. So I would say on my study sheet, I would say, when the first letter is a repeat, and the first letter is a repeated letter, careful. First of all, as many repeats as there are, it doesn't matter. We always put a 1 in the front. Because we don't, like, even if you had 10 A's, right, we would say, no, there's just 1. We're not going to consider all 10 cases because they would all be the same iteration. So it's 1 always. Okay? I will make a note, always 1 if repeats. Thank you for bringing that up, Ojasi. I appreciate that. I need to update my study sheet, my answer key. Thank you, both. That is a good catch. I'm gonna just make sure you're gonna practice that right away. So I'm guessing Mississippi is wrong then too. Did I post Mississippi? Did I post up to 26? I think Mississippi, I did get that right. Every once in a while I get it right. Mississippi is right. Okay. I'm gonna do something new after this. I'm gonna give you a little bit of class time to do the rest of 25 and all of 26 in light of what I just talked about. Okay? If you talk to your neighbor, I'm okay. Just try to keep it as quiet as possible. I want you to figure this out. If you need someone to help you with it, go for it. But let's do 25, 26, and some of you probably did the homework. Way to go. Just sit back, relax, or see if you can help someone. I will say this, if you're done, page 35 if you're done. Continue with 25 for a little bit. I know some of you worked on 35, which is great, which means you finished 25 and 26. Again, bottom of 25. Some of you were wondering, Mr. Erickson, since when did we start to divide? Like before we didn't do that. It's only when you have identical objects or you can't distinguish them, right? So balloons, marbles, sometimes decorations, right? Certain decorations look exactly the same. So the question, I will try my best to make sure, and the province does too, to let you know, oh, okay, these are exactly the same. Okay, I got to make sure I count for that. Okay? So whatever you do, whatever restriction you're trying to fulfill, make sure you also divide. Okay? Divide. Oh, somebody didn't. You divide out, okay? And then Mr. D's son asked him to paint a unique smiley face on each balloon. Now you're making every balloon, whether they have the same color or not, you make every single one be different. So that's why it's a really big number. This is not just 8.71. Please don't do that. If you look at your calculator, it says e to the 10 at the end, right? That is really 10 to the power of whatever follows the e. It's just a really big number. And so when you're like, why would I ever ask for this? If I ask you for it, I would probably not care about the final number. I would just care about how would you solve it, right? You would go 14 factorial, okay? Then the last one is, how many arrangements would not have all the same colors together? Okay, how many arrangements would not? So I basically just go 14 factorial minus the 24 that had them all together. I think this one is controversial, this question. I think even I mixed this up. What is this assuming? If I say 14 factorial, then we're talking about the balloons that now have a smiley face, right? 14 factorial? they all have a smiley face, so every single one matters where they are. When I go minus 24, where did I take this number from? I took it from here where they did not have a smiley face on them yet. Okay, so can you make a correction to this? And I will write down the assumption here. Assumption, they all have a smiley face, right? They all have a smiley face. I'll just go smiley, okay? They're all distinct. They are all unique, okay? Just like you guys all are, right? You're all unique. So now we made them unique. Why did he have to throw that in there? 14 factorial, right? So you go minus, how would we do all the same colors together in this particular case? We've got 4 blue, 5 green, 3 yellows, 2 purples. Okay, we do not, so this would be the 4, 5, 3, 2, and what else needs to be tacked on there? How many groups do you have altogether? You've got 4 factorial. This is like the zoom out part. This is the zooming out part. I'm not going to do the math. We're just going to leave it like that. I just wanted to like throw that in there. The main reason being the not part. Okay. I feel like some of you are scratching your head on where did you get this number from? 1, 2, 14 of them, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have my 4 blues, 5 greens, the 3 yellows, and the 2 purple balloons. Okay, that's where I got the first couple of numbers from. And then I zoom out, and now I just count every slot that when I zoom out, which is 1, 2, 3, 4. So this is the zoom out 4 factorial here. You can't see that, can you? Let me bring that up. 4 factorial like that. So that's how I got them being all together. In this case, I don't need to divide out because they're not exactly the same anymore. All the blues are different. All the reds are different. So I don't have to worry about dividing out. Okay. We're good? Too much? Maybe it's a little bit heavy, right? The Mississippi one, again, that one should be pretty straightforward. You divide out the letters that repeat. But then here, look at this one. This is the one we just did earlier. What if it must start with an I? You've got 4 I's, right? They're all the same, but they're identical, right? So I just turn that into a 1. And then the rest, right, I fill in with 10 all the way to 1 because there's 11 in total. But then watch what happens here. I go 1 times 10 factorial and then divide it by 4. There's 4 S's. There's only 3 I's left because one of them is fixed. Okay, so I will actually highlight that. 1 I is fixed, and it is fixed right up front there. So we don't have to worry about all 4 of them being moved around inside the remaining letters, okay? So I'll just keep it at that. But no matter what, divide out the repeats, especially when it's words with letters, divide out the repeats. I'm going to leave 26 as is. Let's go to 35. A lot of you are working on page 35.